Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the slope, tangent, and convex up and convex down. Concave up and concave down. So first of all, we have to discuss about, we recall some of the tangent rule. So how will you find the tangent? The tangent has the slope. How will you calculate that slope if the 2 points are given? When 2 points are given, the slope of a tangent is given by the formula change of y over change of x. So therefore change in the y over change in x. So y2 minus y1 over x2 minus x1. So this is already we have taken. Now when you have a function is given y equal f of x is given. Now how will you find the slope of the curve? So just you have to take the differentiation. So if you take the derivative, first derivative, this is the slope of a tangent. Now, in the same case, if it is a parametric equation, x is f of t, if x is equal f of t and y is equal g of t, then how will you calculate the slope? This is the slope is going to be the first derivative, but how will you differentiate the dy and dx? So first you have to differentiate the y with respect to t and x with respect to t. After that, divide it, you will get the first derivative dy over dx. So here the third variable is the common variable is a t. Now similarly, the second derivative we can calculate by using the same rule, but I will write it the second derivative d over dt over here dx over dt. So this is the second derivative formula. So in the second derivative, using the second derivative itself, we will find it the concave up or concave down. So if the second derivative is more than 0, it is a convex up. If it is less than 0 for all the x value, so it is downward. When it is equal to 0, there is no concavity. So there is no concavity. Now the next note we have taken as a horizontal tangent and vertical tangent. So you will have the two types of tangent. One is a horizontal, another is a vertical. Suppose if you have a curve like this. So therefore this is the horizontal curve and this is the horizontal tangent. And similarly this one is a vertical tangent. So how will you find this type of tangents? So by substituting that dy over dt equals 0 and dx over dt is not equal 0. Similarly, the next one, the vertical tangent, the dx over dt is equal 0, dy over dt is not equal 0. And this is some basic rules of the sine and cosine n pi, the generalization. So sine n pi is equal 0 for all n value. For sine cosine n pi, the n value is minus 1 to the power n. So depend upon the n value, we will get plus 1, minus 1. It depends on the n. Similarly, the 2n pi, so 2n minus 1 pi over 2, which is equal 0 for all the n value. Here 2n minus 1 pi over 2 for the sine, it becomes the minus 1 to the power n plus 1. So depend upon the n value, we will get plus 1 and minus 1. We will take a one problem. A curve C is defined by the parametric equation x is equals t square, y equals t cube minus 3t, and we will solve the problem. Now we have to show it here. The two tangent. Show that the C has a two tangent at a point. This point is given and find its their equation. First of all, I have to find it the t value. So for that one, I have to find the x given point. What is the given here? The x value is equals 3 given and y value is equals 0. When I substitute as per the x value, this one is t square is equals 3. When you take a root, you will get plus or minus root 3. So this is the t value. When I substitute y equals 0, so y value is equals, So t power 3 minus 3t is equal 0. If you simplify, t is a common factor, t square minus 3 is equal 0. Therefore, you will get t equals 0, t minus 3, t square minus 3 equals 0, t is equal plus or minus root 3. So you will get the two values. So we will need a two tangent. We will not put this one t equals 0. I will tell you why. So we will calculate the two things. What are they? So t is equal root 3 and t is equal minus root 3. So in order to calculate the tangent, I have to first calculate the slope. What is the slope of the tangent? Slope is nothing but the derivative. So what is the derivative? M is equal y dy over dx. So how will you calculate dy over dx? So dy over d theta dt dx over dt. Now when I substitute the value, what will get here? This one dy over dt. So 3x power 2 minus 3 over. So it is 2x 2t. So t square becomes 2t. Now when I substitute the value, this is the m value. So I have to calculate the when t equal root 3. So that's why we are not calculating t equals 0. If I substitute t equals 0, this denominator becomes 0. Therefore, this is not possible. So t equal 0 is not possible. The slope become undefined. So here we will have a t equal root 3. I will just substitute the value. What happened here? Dy over dt becomes, the m becomes, when t equal root 3, so it becomes 3. If you multiply, it becomes 9 minus 3 over 2 root 3. So it is 6 over 2 root 3. If you simplify, you will get here 2 3 times. So if you cancel, you will get root 3. So m is equal root 3. So this is the slope when t equal root 3. So when it is minus root 3, so what is the slope of this tangent? So here the same thing, you will get 9 minus 3 over 2 times. If you multiply, it is minus 2 root 3. So this is 6 minus 2 root 3. If you cancel, this is 3 times. If you cancel the root, you will get minus root 3. So this is the two slope we have calculated. Now how will you find their equation? The equation can be calculated by, so since we have the x value and y value, x is equals 3, y is equals 0 and t is equal root 3, that is m. So we need m. So m is equal root 3. So you will get the equation y minus y1 m times of x minus x1. What is y minus y1? 0 here. Then x, this is root 3 and x minus 3. So when I simplify, you will get y is equal root 3 times of x minus 3. So this is the one of the equation of a tangent. Now the similar thing I have to calculate when the slope is minus. So what happened? This is 3, y is equal 0 and m is equal minus root 3. Same thing I have to write it y minus y1 m minus root 3 x minus 0. So x minus 3, sorry, x minus 3, the x value. Then y is equal minus root 3 into x minus 3. So this is the second equation of a tangent. So using this, we can calculate all the problems. So we will calculate the two tangents by using the point. So this point, it has a two tangent. The next question, it is asking about the tangent. So horizontal tangent and vertical tangent. So as we know from the beginning, the condition for the horizontal tangent, it is dy over dt must be 0. dt must be 0 here, and dx minus dt is not equal 0. Is not equal 0. Similarly, in this case, it is opposite. dx over dt is equal 0 and dy over dt, which is not equal 0. Let us start with this one. Now what we have calculated, dx over dt. So dx over dt is this one. This is your dx over dt, and dy over dt, which is equal this one. Now I will take the same thing. So here we will put it dy over dt, which is equal 3t square minus 3 is equal 0. When I substitute this one, 3t square is equals 3, t square is equal 1, t is equal plus or minus 1. So this is the plus or minus 1. When I substitute in the x and y, you will get the point. This is the tangent, horizontal tangent where the point gives. So here we have a x and y. A y value is 3t power 3 minus 3t. When I substitute 1, the t value is equal 1, the x value is 1, y value is minus 2. When I substitute t is equal minus 1, you will get x is equal again 1, y is equal minus, it become plus, therefore it is 2, 1 comma 2. So this is the 2 point where you will find it the horizontal tangent. Now the similarly the vertical tangent, I have to put it the 2y 2t. So this is a 2t is equal 0 and here t is equal 0. When I substitute in the point in the equation the x and y you have here the parametric equation, you will get the points x comma y. What is the x comma y? X value is 0, y value is also 0. So it is 0 comma 0, you will have a vertical tangent. Vertical tangent. Now the next one I have to find it the concave up and concave down. For that one we need the second derivative. How will you calculate the second derivative? Since we know that the value is equal, we have the x value is t square and the y value is t power 3 minus 3t. Now dx over dt, which is equals 2t, and dy over dt, which is equals 3t square minus 3. So this is already we have calculated. It is simple. Now the dx over dy, the first derivative dy over dt, which is gives the first dy over dt, dx over dt. So what is this value? 3t square minus 3 over 2t. Now after this one, just substitute the value. So what happened here? This one is the first derivative. I want to calculate the second derivative. In order to calculate the second derivative, we need the dy over dx square, the second derivative. So what is the rule we have taken in the before? So we have taken this one as d square y over dx square, which can be written as d over dx of dy over dx. Now how will you remember this rule? This is very simple. Dy over dx, and here you have a d and this is the dx. This is the same thing. Now I just put it over dt over dt. So because the t is a variable which is common in x and y. So this is already modular. Therefore we will have d over dt. Differentiate this part with respect to t. What is this one? 3t square minus 3 over 2t over this is dx over dt, which is equals to t. Now how will you solve this one? How will you solve this one? So this is a simple thing, same thing. Here we will use this one is over t as it is. Over t as it is. Now here we have to use the f over g rule, quotient rule. So what is the quotient rule you will have? This is 4t square. So the rule is g square, g fixed, f differentiate, f fixed, g differentiate. The same rule we are going to follow here. So therefore 2t is common. When you differentiate the f, so you will get the part as 60. The 3 becomes 0. Minus 3 becomes 0. Minus f is fixed. What is the fixed value? F is what? 3t square minus 3t is fixed. Now differentiate the g. What is the g differentiation? G value is 2t. When you differentiate, it becomes 2. So this is the derivative of the above. Now if you simplify this one, how will you simplify? This is a simplification. So what is the simplify here? So it will comes down here. So it becomes 8. So it becomes 8t power 3. And what about this part? This is the first one is 12t square. When you multiply this one inside, what happened? So this is minus 6t square. Minus into minus plus, which is 6. If you simplify, you will get 6t square plus 6 over 8t power 3. Now you can simplify by taking the 2 as a common factor. When you take 2 common, you will get 3t square plus 3 over it is 8t power 3. If you cancel the the common factor, it becomes 4. So this is the final answer for the dy over dx dt. The second derivative. This is the common part. D square y over dx square, which is equals 3t square plus t over 4t power 3. So this is the common part. Now I have to discuss for what is the value of t. So since the value of d square y over dx square, we got it the value as 3t square plus 3 over 4t power 3. So this is 0 more than 0 when t is t is more than 0. If you take a positive value, all the value will be positive. Similarly, this is become less than 0. The dx square, the second derivative is less than 0 when t value is negative. So you can ask why it is negative, because it is a cube here. So due to this cube, since this cube, it becomes the negative value. Therefore, it becomes the less than. Here you will have a positive, both are positive. That's why it is more than. So here we will have when t is equal more than 0. So this is a concave up and concave down. So I write it this one. If it is more than 0, this is concave up. Concave up. And here if it is less than, we say here concave down. Concave down. So if it is equal 0, t value, therefore it is not defined because it is denominator is t, therefore t is not equal 0. Now the sketching, it is the same thing as what we discussed in our previous video. So we have to give the value of x t value as 1, 2, 3. Then you have to substitute the value. So t value is equal 0, t value is equal minus 1, t value is equal 1, and then 2. When I substitute here, it becomes 1, 0, 1, and 4. When I substitute for the y, the value of y here, so it becomes minus 1 minus it becomes plus 2. Then the 0 becomes 0. Then when you substitute 1, it is minus 2. When I substitute 2, 8 minus 6, which is equals 2. So the value will be here. Yes, this part is the first one, 1 comma 0. It is 1 comma 0. It will be here somewhere. 1 comma 2. Then 0 comma 0. Then it goes to the next one. It is 1 comma minus 2. Then it goes to 4, x equal 4, 1, 2, 3, 4, 4 comma 2. It will be here, 4 comma 2. So starting will be here. So this is the point where you will have 3 comma 0. Where is 3 comma 0? 1 2 3. This is 3. So the point 4 is 1 2 3 4. 4 and 2, it will be here, and this point is 3. So it goes up first and it will rotate. So what is this point? This point is 3 comma 0, where in the question it is mentioned. So this is the t equal minus 1. This is the t equal 0. So it is moving here this side, and this one is t equal 1, and this is t equals 2. And where is this tangent points are given? So this is the tangent you will have. This is the tangent. So one tangent, it is, there are two tangent at this point. So one will be like this. This is one tangent, and this is the another tangent. This is another tangent. So this is two tangent at the point 3 comma 0, and this is the direction you have. It is moving like this. Thank you.